All right, the next thing we're going to talk about is going to be circles. We are going to deal with all sorts of circles. Before we get too far, a couple things I want to say about my good friend, the circle. First off, a couple things you should know. Circles, it's not terrible. I've drawn worse. Circles, you need to understand that this distance from a center to the edge is known as the radius. The entire distance across is going to be known as the diameter. If you don't know that, you are fired. Other things that I must know are going to be the following terms. If I have a segment that goes across the circle, this segment right here is going to be known as a chord. A chord is what is created by a line segment that goes from one point on a circle to another point on a circle. Along with the word chord, we are also going to define something called the arc. And the arc is the distance around the circle, often measured in degrees. We are not going to worry about radians here. And the arc is going to be the distance from one point of a chord to another point over a chord. In this case, by creating a chord, I'm actually going to create an arc A as well as an arc B. We're also going to have another thing that we're going to deal with. We are going to have what is known as a... Wow, that's terrible. These are hard to draw. Close enough. We're going to have what is called a tangent. A tangent is not when I go and start talking about something that has nothing to do with it, the topic we're dealing with, but rather the tangent is, I wanted to make sure my mic was on, I realized that would have been terrible. But the tangent is when we take a curve, take a circle, and we look at a point, and we look at the line that would be created from the circle to here. Now, an interesting outcome of the tangent is that the tangent is always perpendicular to the radius. So that's an interesting and useful piece of information. The last and final line that we're going to have to understand is what is known as a secant. The secant is much like a chord. The difference between a secant and a chord is that a secant will intersect a circle 2 times and will extend outside of the circle. We need to know all of this terminology in order to be able to answer the following things. So the first thing we're going to talk about is going to be angles inside a circle. Again, we're going to look at, you know what, I'm just going to use the shape function to come up with my circle. Hopefully, is that the one that I want? Yes, it is. So, angles inside of my circle. The only thing I really wish is that they would put a center in my circle. Now, there are going to be a few things that we have to worry about with these circles. All right? And there's going to be, I don't know why I did the circle there. One of the first things, I guess I'm going to actually bring my circle back. One of the first things we're going to have to realize is that a circle has a full 360. I hope that that's not a surprise. Woohoo. If that is really, wow, that's a really bad center. If that is a surprise, you are doing something terribly, terribly wrong. The first thing we're going to talk about is going to be a inscribed angle to an arc angle. The arc angle being that piece. So an inscribed angle is any angle that can be created by having a set of chords that intersect. In this case, this would be my inscribed angle. And what's interesting about the inscribed angle is how that relates to the arc angle across. what is the angle measure here compared to the angle measure there? And one way we can look at that is we can actually look at what happens as this inscribed angle opens up. As this inscribed angle opens up further and further, eventually we're going to hit a situation where my inscribed angle is going to become a tangent line. And hopefully you know that a line is a 180-degree angle. Well, if that's a 180-degree angle, and that's covering the entire circle, this arc would start from this point and would come all the way around my circle to give me a 360. Which means that the arc that's created was double the angle of my inscribed angle. And that happens to be the relationship here. Double the inscribed angle equals the arc. What this means for us is that if I give you an inscribed set of, let me give you a few things here. So I could give you this blue inscribed angle here. I can give you this red inscribed angle like so. And I can give you this orange inscribed angle like this. Not very large. And I ask you, I tell you that this is a 130-degree angle here. And I ask you, what is the arc that's created between these 2 points A and B? This arc would simply be 260. If I were asking about the blue angle and told you that this was a 58-degree angle, then the arc between my blue A and B would be double this, or 116 degrees. Or if I took the orange between A and B and I told you that this was a measly 19 degrees, then this angle right here would be a 38-degree angle, because when I double it, I get a very small section. Now, this is not the only situation that's going to have all sorts of weird and wacky angles. This is just an inscribed. You'll notice that the intersecting secants, or the chords here, happen to intersect exactly on the curve itself. There will also be situations where we will have, that is a terrible line, good enough, intersecting chords. Now, a couple things that you should remember from geometry, that these right here are vertical angles. So these two angles are the exact same measure. These angles right here would be the exact same measure. And that's going to become useful because when I deal with this, I'm going to typically have some arcs. Let's call this A and arc B. So the angle measure for arc A is going to be whatever A is, and then we've got a B. And I want to know, what is the angle measure here for X? And obviously if I know this X, then I know the other X. If we extend this, if we were to cut this down to where they were intersecting each other and they were basically the same exact line, obviously what would happen is that we wouldn't get an A and a B, nothing interesting. But if we were to make these perpendicular to each other, let's see if I can make something perpendicular. There we go. Now what would happen is that we know that these intersect at a 90-degree angle, and this would prove, And these quarters would be 90 degrees, and we wind up with a giant 90-degree angle. So what we would do, that probably didn't help anybody at all. So what we would do to find angle x here is we would need to figure out what is the average of those two angles. And that's exactly what's going to happen. Is I'm going to take the a plus b and divide that by 2, and that gives me my vertical angle. In this example, if this were, say, 72 and 18, we would say that x is equal to 72 plus 18 divided by 2, which is 90 over 2, 45, which means this would be a 45-degree angle. We cleared that off, came up with another set of chords. And now we're asking about this angle right here. I would need to realize, and if I knew that that was x, and I knew that this was 32, this is going to be 210, this is going to be 11. And I were to ask what x is, what I'd have to realize is I would need to figure out what this missing piece is, which would be 360 minus 210 minus 32 minus 10. So 360 less 252, which is 108. So then what I would do to find x is I'd realize x is simply the 108 plus the 210 all over 2, or the 318 halves, or, oh, good gravy, that is 159 degrees. Which means this is a 159-degree angle. That's a 159-degree angle. And we could actually figure out these missing angles here based off of that information. The last of the angle measures we need to know is going to be intersecting secants outside of the circle. So now we're dealing with secant lines. So these are going to be ones that come outside of the circle now. And they continue on for days. But what's unique about secants is that as long as they are not parallel, we are going to find that these secants will intersect. And they will create two arcs, an arc A and an arc B. And if I want to know what this angle right here is, what I would have to do is I would have to come up with that equation. And that equation happens to be that angle x is equal to half of the difference between these two. In this case, let's say I've got a 22 and a 139-degree angle here. Then what I would realize is x would be 1/2 of the 139 minus the 22, which would be half of the 117, which is whatever that is, 117 halves. Whatever that is, it's a decimal if you wind up being a decimal person, degrees, and you would get your final answer. Drawing another couple secants. This time, let's have a secant here, and let's have a secant. That became a curve, but let's just go with it. 32 and 9. Then what we would do, and if I want to look for x, is x would be half of the 32 less 9, or half of 23. So that would be angle measures inside circles. Next video that I'm going to post is going to be about lengths of things dealing with the same things here. So that was angles. Again, the three things that you needed to take is inscribed, oops, actually we do this, 2 times the inscribed angle is equal to the arc angle. For intersecting chords, we said that the angle is equal to the average of the 2 arcs. And when we had intersecting secants, we said that the angle measure was equal to half the difference of the created arcs. Thank you for watching, and I hope that that was at least semi-useful. If you're looking for what pages, that's like 145-ish. No, that's too far, I think. Maybe it's 145-ish to like 160. This is the circle section if you're looking through your stuff. End of section 2.